This question says, find the x-intercepts and y-intercept of the function. I like to find the y-intercepts first. They're usually a little bit easier. So to find a y-intercept, we're going to let x equal 0. So essentially we're calculating f of 0. So everywhere I see an x, I'll change it to a 0. That's 3 times 0 minus 21. 3 times 0 is 0, and 0 minus 21 is negative 21. So the y-intercept for this function is the ordered pair 0, negative 21. Then we want to find the x-intercept. To find the x-intercept, you let y equal 0. And in our function notation, f of x is what represents y. So we're letting f of x equal 0. That would give us 0 equals 3x minus 21. And we'll solve that equation by adding 21 to both sides. That gives me 21 equals 3x. I'm going to solve for x by dividing by 3. That gives me x equals 7. And my x-intercept is the ordered pair 7, 0. This question says, use the vertical line test to determine whether the graph represents a function. So we're given this picture of a graph. That graph will be a relation, but we want to know if that graph is a function. So we use the vertical line test to determine this. In the vertical line test, we're drawing vertical lines all over the graph. And as we draw the vertical lines, we're counting how many times that vertical line crosses the graph. So for this vertical line, we have one time where the vertical line crosses the graph. Here, one time. On this one, it crosses in 3 places. Here it crosses in 3 places. Here it crosses in 1 place. And here it crosses in 1 place. And what we want for something to be a function, we want to have exactly 1 y value. That's the definition of a function, that every x has exactly 1 y. So when we have these situations where the vertical line will cross the graph in more than 1, so we'll say 1 because we're looking for exactly 1. So we have these places where the vertical line crosses the graph in more than 1 place. These are places where the graph is violating the definition of a function, where you have 1 x value with more than 1 y value. So since we have a couple places where vertical lines cross in more than 1 place, this is not a function. This question says, find the x and y intercepts of the graph of the given equation. Our equation is y equals 5x minus 6. I'll find the y-intercept first by letting x equal 0. So I'll substitute in for x a 0, and that gives me y equals 0 minus 6, and y equals negative 6. So this graph will have a y-intercept at 0, negative 6. Then I want to find the x-intercept. To find the x-intercept, you're going to let y equal 0. So I'll substitute a 0 in for y in my equation. That gives me 0 equals 5x minus 6. And I'll solve the equation for x. I'm adding 6 to both sides to get the x by itself. And I'll divide by 5 on both sides to get the x by itself. And I have x equals 6/5. So my x-intercept is 6/5, 0. This question says, classify the given function as a polynomial function, a rational function, or a root function, and then find the domain. Write the domain in interval notation. Our function is f of x equals 4x to the 5th minus 3x, which is a polynomial function. So I thought I'd pause for a minute to make sure you understand what a polynomial function is. A polynomial function is one of the form f of x equals a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus ... meaning the pattern continues until you get to a sub 1 x plus a sub naught, or a sub 0. And this is where n being that power on the variable, n is a non-negative integer. So remind you what non-negative integers are. Those are 0, 1, 2, 3. Those are our counting numbers. So the counting numbers are what's allowed in our exponent. And the coefficients, a sub n minus 1, and so on, these coefficients that are attached to the variable, those are real numbers. For practical identification, you're looking for the variable to be in the numerator. So if there are no fractions, like our example here, we consider all of these terms to be in the numerator, even though we don't see a fraction, because we can always create a fraction by dividing by 1. So we consider those terms to be in the numerator. The variable should not be inside a radical or absolute value, and the powers should be whole numbers. Whole numbers are our counting numbers here. 0, 1, 2, and so on. So if we look at our example on our variable x to the 5th, 5 is a non-negative integer or a whole number. And on the other term, x with no power, we assume that power to be a 1. And that is also on this list. So this is a polynomial function. And what's really nice about polynomial functions is that there are no restrictions to the domain. We're allowed to substitute any value for x. So since there are no restrictions, our domain will be all real numbers, or negative infinity to infinity. So there's not any calculation needed to find the domain of a polynomial function. You just have to be able to recognize when you have a polynomial function and understand that there are no restrictions and the domain will be all real numbers. This question says find the center, radius, and intercepts of the circle given below, and then sketch the graph of the circle. So in order to figure out the center, the radius of this circle, we need to know the standard form of a circle. The standard form of the circle is x minus h squared plus y minus k squared equals r squared. And the center is the ordered pair hk, and the radius is r. So for our equation, we have x versus x minus h. So we don't have a number that's added or subtracted there, so we're going to use h to be 0. And the same thing goes with the y term. Y is by itself. There's no number added or subtracted. So for our center, we're going to use the origin, which is 0, 0. And then we can see on the end, we have 36, which will represent r squared. R squared is 36, and we can square root both sides to get r equals plus or minus 6. The radius is a distance, so it'll be positive, so we'll use the positive 6 as the radius. So we have a center of 0, 0, and a radius of 6. Then we need to find the intercepts of the circle. I'll find the y-intercept by letting x equal 0. I'll substitute a 0 into the equation to get 0 squared plus y squared equals 36. 0 squared is 0. Y squared plus 0 is y squared. And then I'll square root both sides to get y equals plus and minus 6. So we have two y-intercepts at 0, 6, and 0, negative 6. Then I'll find the x-intercepts by letting y equal 0. I'll substitute a 0 in for y to give x squared plus 0 squared equals 36. 0 squared is 0. X squared plus 0 is x squared. And then I'll square root both sides to solve for x. That gives me x equals plus and minus 6. We have x-intercepts of 6, 0 and negative 6, 0. So to draw the circle, I would go to the origin, which is where the center is, and I would count the amount of the radius in each direction coming out from the center. And I would mark those spots. And then we would draw the circle, connecting those points that we found from the radius. A very common mistake on this question using MyMathLab would be to count at an angle. We know from experience that if we have a grid, that if this is 1 unit and this is 1 unit, that our diagonal will not be 1 unit. Our diagonal will be longer. So make sure that when you're marking out the points that will be on the circle that you count either vertically or horizontally.